Hello and welcome to our today's webinar. My name is Göran and I will guide you through our today's event. Well, this day we will have a closer look into web-based reactive software development. And thinking about this, you will run into Rxjs for sure, since it's a very good library for archiving asynchronous behaviors. Well, before handing over to our today's expert, Yannick, who will share his knowledge of Rxjs with you, I need some moments of your attention to have you all information you need to make the most of our today's event. So I will share some slides with you. And hopefully you will see our nice slides. They are not too much, it's just 5, so let's start. Well, one very important part is that you are welcome to participate in the webinar. As I see on the right-hand side, you're using the chat already. Please give us a hi and yeah, well, you can let us know from where you are attending. Would be great to know. If you run into any questions during the webinar, feel free to put them into the Q&A section so we can take a closer look after Yannick is finished with his talk. And there's a possibility to upvote questions, so we got a nice order when we take a closer look later on. One question I can answer previous to the webinar and the Q&A is that you will receive an email with a link containing pointing you to the video recording, code, slide deck, and potential additional content after the webinar by email, so you can have a closer look when you've got a little bit more of time maybe. After the webinar, or if you have to leave earlier, and it would be great for us to have some feedback from you. So please use the, well, a little bit hidden exit function. There are 3 black dots on the upper hand right side. And please use them to exit the webinar. When you do so, you will be forwarded to our feedback website. And as I mentioned, it would be great for us to have your feedback so we can improve our webinars. Yeah, well, that's all from my side for now. See you later for the Q&A part of the webinar. And well, Yannick, the stage is yours. Rock and roll.
Well, thank you for the introduction and welcome everyone. My name is Yannick. I will start sharing my screen and hope that that will work. That is interesting. There we go. I hope you can all see the slides. In case you haven't met me, as I said, my name is Yannick. I'm a software architect for Thinktecture. I am knees deep in Rxjs and other reactive technology in front-end development especially. But what I want to do here is I want to give you guys a good introduction to what Rxjs does, why we should consider using it, and what it can do for us. And yeah, we've seen that a lot of people have problems in applying some fundamental concepts of Rxjs, and I'm going to introduce them to you one by one with examples. And I hope that in the end, we are all a bit more familiar with this great technology, as I may say so. So the first question that we need to answer is why streams? I think everyone who is here should be familiar that the whole concept of Rxjs would be the stream-based data flows. So why streams? Essentially, the whole thing started, or like we need ways to handle asynchronicity, or whatever way that is pronounced. So in our applications that we write, especially in our web applications, but essentially in all applications, we essentially have to deal with several forms of asynchronicity. And in web development, we encounter, for example, WebSockets, DOM events, or AJAX requests. And the question is, how can we deal with that? So one of the first concepts that was developed were promises. So promises the sole purpose of promises is to handle asynchronicity, to essentially defer execution of code. Like, we do not know when a certain piece of code is done or replies, when we get a reply from whatever source there is, and we want to know when that was done and continue execution of a certain function, right? So promises are great to handle asynchronicity. The problem is, well, not the problem, but promises can only do one thing. They can either resolve or reject. Like, there's a single event they can handle. So if you, for example, wrap your Ajax request into promise, it will either resolve if the HTTP request was successful, or it will reject. So essentially, an HTTP request is very simple because it's a single event, right? You send the request, you get the reply or the error is your single event. Furthermore, promises, as soon as you create them in your code, right, they start running. So as soon as you create your promise, the promise will be executed. There's no way for you to control when that happens unless you put it into a function and then start that function. But technically, the moment the promise is created, it starts running. And furthermore, unless you do a lot of infrastructural work, promises are not cancelable. So you create them, they run. There's no way for you to, while it's running, to tell it to cancel what's there in the basic form of promises. So, as I said, promises can handle a single event. What happens if you want to handle multiple events, right? So in software development, there are software design principles or software design patterns. Maybe some of you have encountered the book of the Gang of Four or Gang of Five. I don't remember. There's a book, or there are lots of software principles that have proven to be useful when you run into certain problems. And the observer pattern is one of these problems. So what I'm going to describe here is the observer pattern. So it works like this. You have a subject, which is like your source in the whole setup. And you can register to the subject and wait for the subject to notify you when it wants to notify you. In the case of the HTTP request, we could register to the HTTP request and be notified when it is returning, like when it is successful or erroneous. So the idea of the observer pattern is that you have your source and you have like people, the observers, that are notified. So the observers can tell the subject that they are interested. We call this register or subscribing. And they can also tell the source, the subject, they can tell it when they are not interested anymore, and they can unregister with the subject. So what is great about this is that the subject determines when data flows, when the observers are notified. And the great thing is that you can do this more than once, right? As long as people or observers are interested and registered, you can send them events over and over again until they unregister. So the observer pattern is one design pattern that helps you handle a flow of multiple events. So if we go further, what we're doing is essentially we are developing reactive systems. So one form of working with reactive systems or developing them is we can use a programming paradigm which is called reactive programming. So for example, pretty much almost all of the things you're interacting with, all the machines you're interacting with, they are kind of a reactive system. For example, the ATM. The ATM is just sitting there waiting for you to press a button. So it's reacting to your input, right? So it's just waiting, and once you press the button, it reacts. So wouldn't it be great, because you can press this button multiple times. It's not even a button. It could be the screen where you touch it, whatever. All of these are events that we need to react, right? It could be user input, could be data updates that I want to propagate through my system. There's these kinds of asynchronous events happening, and in reactive systems, we encounter that a lot. And as we've seen, we have a lot of different events that we could potentially have to handle, right? We talked about WebSockets, async requests, DOM events, whatever there is, user input, data changes, everything. So enter Rx, reactive extensions. There are multiple implementations in a variety of languages, and we are talking in particular about Rxjs, which is the whole thing in JavaScript. So the only thing the library essentially does is it implements this observer pattern. And what it gives us in return is it gives us an API in which we can use to describe data streams, like essentially how the data flows from a source or from multiple sources, combine the data, and we can subscribe to the point where we are interested. Like when this data changes, we want to do something. We want to listen to the changes of the data. And the great thing about the observer patterns and thus Rx is that we can handle multiple of these reactive events. For example, imagine you're reacting to mouse button clicks, right? It's not just one click and done. You can click multiple times. You can click as many times you want. And every time you click, you want to react to it. You want to listen to when clicks happen. So furthermore, what Rx is giving us, it gives us, which you've probably encountered, a huge list of operators. I think there are around 104 or 106. There are more than 100 operators that help us design the way the data flows. Like there's so many useful things. You can, like, assuming there is your observable is failing, you want to retry it. You can handle errors. You can combine streams. You can filter streams. For example, you only want mouse clicks when your mouse position is on the right side of the screen or something. You can filter these data streams. There's a lot of things you can do. And this is what we want to talk about. And especially for Angular developers, I want to say Observables or Rxjs was introduced to Angular mostly in terms of the HTTP clients. So you encounter observables when you're working with the HTTP client. And as we know, an HTTP request is a single event. But what I want to say, or what I want to propose, or essentially the further you go with developing reactive applications, you can see that you can use observables for more than just HTTP requests. And this is an important takeaway at this point. So you can go beyond just using HTTP client and use observables there. So now, what are observables and streams, or what is the whole thing doing? We've talked a lot about observables and streams. Obviously, I said that Rx is the library with which we can, model the data flow, or we can model these streams and manipulate them. And observables are essentially the name or the type of what we can observe. There are different types, as we will see further into this webinar. So just the quick rundown. Again, this is just a summary of what we talked about before. So observables are, again, just like promises, meant to handle asynchronicity. And the difference to promise would be here that an observer, we can control when it starts, right? We will see that also a bit later, but as I said in the promise, as soon as you create the promise, it starts running its code, right? The observer will only start producing values, at least cold observers, will start producing values and when there is a subscriber. So we are in control when this logic should be executed, when the request should be made. Again, observables can handle multiple events, but multiple could also mean 0. You could have a stream that does not emit an event. The promise cannot do that. You need to resolve or reject, but you cannot do nothing. Technically, you could, but the users of your API will be really angry with you. So observables can be also unsubscribed from. You cannot really do that with a promise. So you can notify the sequence or the source that you are done listening to it, and so it can react. For example, in the case of HTTP, if you would cancel your subscription or tell the observer, hey, I'm done listening to you, it could cancel the HTTP request or close your WebSocket connection, whatever there is. A promise cannot do that for you. So the rest is just what we've talked about. We can use observables to communicate change in data, right? If I have my data model and it changes and I want to update my view, I can react to only the point when data has changed and not the whole time, right? I don't need to poll anything. I can just, oh, there's new data, I render my view. So this is what Rxjs is great at. This is what the observables and streams are all about. And what I want to do here is I want to give you a practical introduction to working with Rxjs. So what I'm going to do is I will talk about the bits and pieces that make up Rxjs, and I will demonstrate them live in code with you so we can see how things are executed and how all of these bits and pieces move together. So first we need to talk about the basic, the basic pillars of Rxjs architecture. As we've already seen, there is the observable, and observable is just the data stream or the data source emitting data over time. It's just something that I can observe, thus it is observable. The observer is the function, essentially it's like a callback, right? The observer is something that wants to register with the observable. So the observer knows what to notify. That's me, that's the observer. I want to observe data, I'm the observer. Here is what I can define what should happen when there is new data. This is what we call the observer. Then there's the subscription. We refer to the subscription as the connection between the observer and the observer. So as soon as you subscribe with an observer to an observable, you will get the subscription. As I put it down here, it's a one-sided connection because, well, we register with the observable and we get the data. We cannot send data to the observable. However, we can tell it that we are unsubscribed because technically the observable, like the subject, the data source in the observer pattern, it needs to have a list of all its observers. So when you tell it to unregister, we can throw one observer out of the list. So we are in control. And lastly, a very important part is also the operators. And what I put down there is operators replace the observables with a modified one, with a modified observable. This is a really important step, but my time is very limited. This webinar is already going very long with 90 minutes, but there will be a second part where I go kind of deep dive into operators and how they work and what they are. For now, we are mostly concerned with the basics, all the events that are going. But if you're interested by that time, so if I don't bore you to death today and you take something with, you can be on the lookout for the second part of this webinar where I will be talking about operators in detail. So if you want to be notified of that, maybe you should follow us on social media like Twitter or something, then you can be sure to not miss it, or check our website from time to time, or subscribe to our newsletter. Do not miss it, because it is essentially, well, it is essential as it is one of the 4 pillars of Rxjs. Good, that's enough shilling. Let's go further. So the first thing that we want to do is, how do we get started with all of this? Well, we want to create an observable. If there's no observable, there's nothing to observe, right? So there are several ways of creating observables. So one of the ways, the simplest, the most bare bones basic way, if you want to create an observable, is you just create an observable using the observable constructor. So we create a new observable here, and what we get is a function. So we define a function. In this function, the parameter that we expect is an observer. And as we can see here on the observer, we expect certain methods, like the next method. There's a complete method, there's an arrow method. We will look into that a bit later. But essentially, this is all, right? This is how you create an observer. In most of the cases, you don't need this form because there are operators for you. We call them creation operators. There's from, there's of, there are several, right, that you can use. So it's very rare for you that you actually have to create your own observable. However, if you have a library, for example, you're using a JavaScript library for connecting to a database or something, and you want to have an observable API, then what you could do is you could wrap that. Or when you're working with WebSockets, you can wrap any library that you want, any asynchronous behavior, you can wrap it yourself in an observer. So we are going to look at how this works. So I have an example here. So I hope you can all read this, my code editor, and you can see my terminal. So let's first look into the code here and see what's happening. So there's a variable that we call source $. You will see a lot in Angular development. You will see that observables or async, observable things usually are postfixed with a $sign. So I have a variable called source, and what I do is I create a new observer. Again, I create this observer. On this observer, in order to tell the observer there is a new value, I just use the next value, the next function on the observer. So essentially what I'm doing here is I am the observable. I am the source in the observer pattern. And when someone registers to me, I will send it two values. I will send it value 1, value 2, and I will tell it there are no more values. And this function here, as you can see, my function returns a function. This is the function that is called or executed when an observer unsubscribes, right? So when that happens, we will be looking into, but this is what you need to know. It's good for cleanup logic. I will show you in a second. So what we expect now is we have the source here and we subscribe. As I said, subscription means we connect our observer. This will be our observer. In this case, we have a simple function. So the function says if there's a value v coming through the stream, we will just do a console log. So what do we expect? We expect receiving value 1, receiving value 2, completing, and then unsubscribing. So the observer is unsubscribed. Down here, we do the same thing, except for instead of creating the observable ourselves, we use the from method. And technically, it does the same thing. It will emit value 1, value 2, and it will complete. So we will see again, value 1 received, value 2 received. That's it. We will not see this because there's no unsubscribe function for us to have control over. So now let's just run this example and see what happens. And here we can see that essentially what I just said happened, right? So up here, we receive value 1, we will receive value 2, and then because it's completing, we can unsubscribe of the data source, and well, this function is called. Down here, the same thing is happening. Once we connect, we get value 1 and value 2. Now, it's kind of cheating because I did a lot of things that I didn't tell you about, but don't worry, I got you covered. This is what we are talking about next. There's one thing I would like to ask you to do. I get messages that my network quality is suffering. I wonder if everything's good on your side. Can you hear me well? Can you see me well? Is everything good? Maybe you can give me a quick feedback on that, or if my voice is cutting out, I'd love to know about that.
Well, from my side, everything's great so far.
Okay, perfect. Then it's just the platform. Good. Thank you very much. So then let's go on. Thank you. Thank you for the feedback. So next, error complete. What are these? Well, technically you could call them events. These are the events we can react to, but on the other hand side, what they are is they are functions that we expect our observer to provide. So on our observer, we expect a next function, an error function, complete function. This is how our source, the observer, we as a provider of values, can send data to all the people that are notified to us, that are registered with us. So as you've seen already, the next method is very simple, right? The next method means this is the method I call when I want to tell my observers there is a new point of data. There's new data. Then here's the error method. When I run into trouble, I can throw an error, or I can call the error method on the observer. So what happens is I give my observer the message that an error has happened, so it can react to that. For example, your HTTP request failing, I will emit an error. So you can react that to a not a successful data imitation, you will react to an error. So what happens when we call this error method? What happens is that afterwards, we cannot emit more values. Like we as a data source, we ensure, hey, we sent an error, we are not gonna have more values. So what the observer can do, and they do that automatically for you, when we receive an error as an observer, we know there's not more data coming. So what we can do is we unsubscribe. This is handled for you automatically by Rxjs. So once you receive an error, observers will unsubscribe and the observer does not complete. But what is completion, you might ask? Well, here we go. There's a third event, which is the complete event, which you have already seen. So what the observer, the data source, can do is I can tell my observers, I'm done. There is no more data coming, right? So I will complete, I will not send you more data. I'm done with emitting values. In our case before, there was value 1, value 2, and I'm telling you there's nothing more coming. So when I tell you there's nothing more coming, natural reaction to that would be, okay, I'm not interested in you anymore, so let's unsubscribe. And this is what's happening. Rxjs does that for you. So once you send the complete, the observers will unsubscribe, and we've seen that in our example. Here I tell you value 1, value 2, complete. So this subscription here, this observer, which is very simple here, it has only one function, the next function. This is the next function, right? And this next function is called this observer here, this next function. This is the function that's executed. So value 1, value 2, complete. Once we are complete, this observer here can disconnect. It can unsubscribe. Thus, this function is executed. So that's why we get the message observer unsubscribed here. Good. So these are the two really important points. When there's an error, observers will unsubscribe. When they complete, observers will unsubscribe. For example, in the case of HTTP, if we do a GET request, it's okay. We get one value. There is nothing more coming. We can complete, so our observers can unsubscribe because they are not going to get more than this one value. So that's why the HTTP client will unsubscribe. Like subscriptions to the HTTP client will unsubscribe for you technically because they will complete. Good. Anyway, I'm going to show you what this looks like in code. So what I'm doing up here is also a bit of cheating, but I'm creating an observable in a different way. What I do is, first of all, we've seen this, right? This from is going to create an observable for me that will emit 3 values, will emit 10, 20, 30. This observable here will create the values 40, 50, 60 and complete. This one, 10, 20, 30, complete, 40, 50, 60, complete. Here is an operator, a creational operator that is called concat. As you know, concatenation means we just append something at the end of something else. So we concatenate things. So what we do is, here we have this first observable. What concat does is, once the first observable in the list completes, it will start emitting the values of the second observable until it completes. So if this first observer completes, we will go on with 40, 50, 60. So what we expect from this source, we expect the source to emit 10, 20, 30, 40, 50, 60, complete. And down here, we have our observer. In this case, we use the more elaborate form of creating observer. This is our observer. It's an object that gives you 3 methods. All of these are optional, by the way. As you've seen before here, I do not have a complete method here in this. I only provided this the simplest form. I only provide you with the next method. I can still call complete. It's just an interface that's filled for me, right? So don't worry about this. We could just throw one of these away. So this is my observer. What do we do? When there's a next, when there's a value, we just console log next. When there's an error, we console log it, and we console log on complete. So let's run this. There we go. We expect 10, 20, 30, 40, 50, 60, complete. Here we go. Well, how does that work? Well, the concat observable, once the first observable in the list completes, we add the next one. We can do this. We can add way more than this, and it will just append them at the end once the previous one completes. Now, what I also want to show you is what happens when one of these observables throws. What this throw error does is it's also creating an observable for us. It is essentially the same as this, but what we do here, we just throw instantly. So essentially not throw, we just communicate an error instantly, right? This is essentially what throw error does. It creates an observable, we can subscribe to it, but as soon as we subscribe, it will call the error function on the observer. So what can I do? I can concatenate this observable into my list of observables. So what do we expect? We expect 10, 20, 30. This thing completes. Then concat will add the next observable. So it will then throw an error. So as I said before, right? This is a creation of an observable. What do we expect from this observable? 10, 20, 30, error. Now, if we look at the slide, I say if there's an error, we do not unsubscribe, we unsubscribe, we do not complete. So we expect that the error function is called, but not the complete function, our observer. So let's save this. Let's run it. Here we go. 10, 20, 30, error. You can see if you observe the errors, your complete function is not called. It's important. Error, no complete. Error, unsubscribe, no complete. Complete, unsubscribe, no error. Right? Makes sense. Sounds more complicated than it should be. But technically, that's how it works. This is what I want to show you. Now, the next example I have is I have this cleanup example. I told you about the function here, right? Here, what do I do here? I create another observable. It emits a value. Here, I will count, set an interval, which is kind of asynchronous. So every second, right? Every second, I will emit a new value, the next value. So technically, what I do is every second, I will emit a value to you. It will start with value 1, then 2, 3, 4. And if it gets bigger than 6, right? Bigger than 5, sorry, we will throw an error. And down here, we return in this function where we do our observable logic, where we notify our observers. In this function, returns a function, which is this cleanup function, the unsubscribe function, which is called once a source completes or unsubscribes, right? Once our observer unsubscribes. So what we do in this case is we have a handle onto this set interval. And once our observers unsubscribe, we want to clear that interval. So let's see what this example does. We go for T is node. It's number 3. So every second we are emitting a value. We get 5, and after 5 there will be an error. And we clear the interval. Here I have this console log emitting. So every second I will also console log that this timer is still running, because what I want to show you is what happens if we do not clear the interval, right? This thing will still error. This thing will unsubscribe. Oh, 5 values coming our way. Error, right? So observable errored with this function. Let's kill this. But as you can see, this timer is still running, because why would the timer be stopped? How could Rxjs or anyone know that there is a timer that needs to be stopped? So this is why this clear function is really important. For example, if you do a database connection, WebSocket connection, if your observer unsubscribes, maybe you want to close this connection, right? Or in the case of the HTTP example, the HTTP client of Angular, if you unsubscribe before it has emitted, it can cancel the HTTP request for you, right? There is a way to cancel AJAX requests. With a promise, not really possible. So what I also want to show you is that there are several ways. Oh yeah, what I do want to show you is instead of erroring, we can also complete, right? So in the 6th emit, we were just, after the 5th emit, we will just complete. And what we can see is, again, 3, 4, 5, boom, we complete, and you can see the complete function is called because we tell it to complete. And we can see that once we complete, Rxjs will unsubscribe for us, meaning this function here is called, the interval is cleared, we're done. Cleanup logic, really important. One more tidbit I want to show you here. For example, we could, right, kill the observer or the subscription preemptively. For example, we can unsubscribe after, that's great. Let me quickly import that for you. Rxjs, yes, operators, there we go. So what take does, right? It's an operator here in the pipe, and it tells the, essentially what it does, it kills the connection after 3 emits. So what I want to show you is that this operator, there is several ways to unsubscribe from the source. One is via operator. There are several operators that do that for you. Take 3 or take is one of them. See, we do 1, 2, 3, and this kills the connection for us, but we can go into that in more detail in the next part of the webinar if you're still interested. So after this happens, this function is called as well, because there will be an unsubscription. And what happens here is it will complete. Technically, what happens, this, as I said, a operator replaces an observable. So we have the source observable. This take operator subscribes to the source observable. And once it reaches 3, it will unsubscribe from the source observable and will, on this own observable that we are now subscribing to, what we are subscribing to here is not the source, we are subscribing to the take operator here. So the take operator will kill the connection to the source and it will complete. This is what's happening here. 1, 2, 3 values, complete, meaning unsubscription, meaning interval is cleared, everything's good, right? This is how this works. This is how these 3 events interact with each other. Good, perfect. Next, subjects and observables. Let me quickly take a look at the question. Interesting question. We will go into that later from Christian because I want to get through to this and then I can reply to you in more detail. So subject and observable. There is hot and cold. Maybe you've heard about hot and cold observables. So what is hot and cold? Observable is a data stream and a source that's emitting data over time, like we've seen before. An observable per se is cold. And what cold means, essentially, it means unicast. And this actually will answer, if you listen closely, Chris Fahl, I think is your name. Christian Fahl, exactly. If you listen closely, this will actually answer your question. So this observable, right, the general observable that we made, that we created here, this, or actually I have an example here, right? It will start running once we subscribe. If there's no subscription, it will not run. Why is that? Pretty simple. A cold observable is a unicast observable. That means every time someone subscribes, there is a new execution context, which means an observable technically only has a single listener, unicast. So what happens here in this example? We have this observable that you've seen before, right? First, let's just run the example. It's pretty much the same we've seen already. Here is node number 4. So we expect to receive value 1, value 2, completion, unsubscription. So again, this is what's happening here. We receive the first subscription. We get value 1, value 2, unsubscribe. Now we can see here there's a second subscription. And as you can see, it's the same values again. It's again value 1, value 2, value 1, value 2. Same thing happening down here, right? Because this from is essentially the same as this. So we can just throw this out. But what I want to show here is that from is also cold. So what does this whole thing, cold and execution context, mean? If you look at this, right, very simple. What people tend to forget once they're working with frameworks or libraries, they tend to forget that it's in the end still JavaScript. There's no magic happening here, right? This is a great API that might hide the fact that's happening from you. But what we are doing here simply is this subscribe, right? This is an observable. Source is an observable object. An observable object has a subscribe method. What this subscribe does is it calls this function here that we are providing in the constructor. So once we create this, we have a reference to this function. And what we do with this subscribe, we give it this observer object. So this thing here, this function, is our observer object. It's just a very brief form of it. Because what this subscribe does for us, it creates the observer object for us that essentially looks like this with next function and error function and complete function, right? So this thing becomes the observer here. So as you can see, every time this subscribe is called, this function is called. And this is what I mean by new execution context. Every time we subscribe, this function is called. So that means this here is happening. So that's why every time I subscribe, and if I do not subscribe, nothing's going to be happening, right? We can go here. We can go do console.log observer subscribed, right? Subscribed. Let's go with this, right? I can show you that nothing's happening. This function here is never called. That's what we mean by cold observer. It needs starting energy, namely a subscription. So once I subscribe, we see, hey, an observer subscribed. Here, give it value 1, value 2, complete. Perfect, we receive the values. It's complete, we unsubscribe. This function is called, boom, done. This is what a cold observable is. So in case of Christian Fahl's question, it should be clear now that, well, let me read the question again. The question was, the cleaning is done after the last observer unsubscribed, right? Was the question. The answer is, well, there is only one observer. Once it unsubscribes, the last observer is unsubscribed. But there's no way for me to subscribe to this source observer multiple times because it is a cold observable. Unicast. New execution context with every subscription. So what if we want to do multicast? What if there are 5 to 10 people who want to listen to data updates, right? This is where subjects come into play. So first of all, one more important thing, right? If you're working with Angular, I'm sorry, eventually, like sometimes I need to talk about Angular because this is what I do. Maybe some of you are too. In case of Angular, the HTTP client, right? This is what happens. Sometimes if several subscribers subscribe to the HTTP client, right? To the same, let's assume you have a service that says get data. And in this get data, there is an HTTP client get. What happens is the HTTP client get is happening in here. So if you subscribe to that thing 3 times, the HTTP request will happen 3 times. This is important. A lot of people don't see it and then they are confused why this is happening. Well, the HTTP client get is cold. It will only start running once there's a subscription. If there are several subscriptions, each subscription will call this function, thus several HTTP requests. Quick side note, quick aside, whatever. Subjects. What are subjects? Subjects. There are several types of subjects. There's a basic subject, async subject, behavior subject, replay subject. I will show you all of them in the next couple of minutes. And this is an observable that we can tell when to call these methods. So I like to do, like, for illustration purposes, I like to imagine I have a remote control and I'm controlling this subject. So on my remote control, there are buttons. There's a next, error, and complete button. And when I press these buttons, this subject will call these methods. So now this thing is multicast. That thing exists. I create it and it exists. So I can emit data when I press the button on right remote control. When I press next, it will next. It will call the next method of all its observers. If there are no observers, no one will get the value. If there are observers, they will get the value. This is how you do multicast. So you have 3 observers. I press the next button, 3 observers will get it. If I press the complete button, all 3 will get the complete notification. So if you have multiple listeners, if you want to do multicast, you need a hot observable. So subjects are hot. Once you create them, they're there. They do not go anywhere until you tell it to complete or do whatever. So here's our example. It's a bit longer, but I want to really take my time and make you understand all of the moving parts of Rxjs. So this is, let's look at this, right? Here my source is not an, well, technically a subject is also an observable because I can observe it. This is the interface. I can subscribe to it, right? So this subject is my data source. This is the thing I have the remote control of. I have this subject essentially my remote control. So what I do is I press my next button and I want to emit value 1. This is what's happening here. And as you can see here, I'm not subscribed to it yet. So nothing's going to happen with value 1. Then we have ourselves our first observer entering the game. Here we go. Our first observer registers all of these methods. So once there's a value coming through, I want to call the next function. Then I press my button again to emit value 2. Then another observer will subscribe. I press my button. Observer 1 will unsubscribe. I press my button. Observer 2 will unsubscribe. I press my button for value 5. Perfect. And then I press my button for complete. And then afterwards, once I've pressed complete already, there is another observer coming. So let's look at the result of this and make some observations. Wait a second. This is wrong. You have not seen anything. We want to go for example 5. I was getting ahead of myself. There we go. Here we go. We see value 2, 3, 3, 4. Why? Here is our first observer. Our first observer only gets the values 2 and 3. Our second observer will get the values 3 and 4. And our third observer will only get the complete. So why is that? Well, perfect. We create the subject and I press my button value 1. There's no one listening to it yet. No one gets value 1. Now, the first observer subscribes, makes a connection. Now I press value 2 because I can. It's not because it's subscribed. It's just at this point in time, I decide to press this button. So this one is subscribed. So our observer 1 gets value 2, right? Now another observer comes, registers. So now we have 2 observers. Value 1 and 2 are already gone. Now I press the button for value 3, and you can see that observer 1 and observer 2 get value 3. So with a hot observer, because it's running already, you can miss values, obviously, right? With the cold observer, you cannot, because you're subscribing and things starts running once you subscribe. Good. Here, sub 1, first observer goes out, disconnects, perfect. I can still press my button because I can press them all day long. And we see value 4 is only received by observer 2 because observer 1 is gone. Now observer 2 is going, perfect. I press button for value 5. Nothing's happening because, well, it is happening. I'm calling the next method of all the observers are registered. There are none. We don't see a thing because there are none. No one receives the value. And then I press the complete button, which tells this subject to complete. And here is sub 3, which comes after the fact, after I've completed. And you can see what happens if you subscribe to a hot observable that's already completed. The complete function will be called for you immediately. Whoops. Now, same thing for error. I will, instead of completing, I will throw the error here, just for illustration purposes. We see, instead of completing, if we subscribe after the fact, we will get the error. And as you can see, the other observables, they did not get the error because they jumped off the boat once before the error came. Good. Hot observables, easy. So what I want to show you next is there are different types of subjects that have niche use cases, maybe. So there's the first subject that is what we've seen right now. There is nothing special about it. We just have the remote control repress the buttons. Perfect. Nothing's happening. What I want to talk about next is the async subject. What the async subject does, it only emits the last value after the subject completes. What does that mean? I again have my async subject remote control. I press all the values as much as I like, then I press complete. And what happens is this subject will only press the push out emit next on all observers, will only next the last value I pressed, the last value I nexted before I complete, right? It remembers all of the values. It remembers the last value that I press. So if I press 1, 2, 3, 4, 5, it now only remembers the 5. I press 1, remembers the 1, 2, 3, now remembers the 3, 4, 5, it remembers the 5. Complete, it sends the 5. This is what it does. So let's look at this. We have this async subject, my remote control. We have my pressing next. Here is my first observer entering the game. I press value 2, value 3. Then I press the complete button, and then there is another observer joining. So let's run this as we've done before already. T is node number, this time it's number 6. Perfect. Boom. What do we see? We see nothing happens with value 1. First of all, no one was listening to it anyway. Now we have a first subscriber, right? I press value 2. It doesn't get value 2 because we are an async subject. It doesn't get value 3 because it's an async subject. Now we complete. This is when the async subject decides, now is when I want to next. So it nexts the last value it remembers, which is value 3. Good. Here is, again, an observer coming after the fact. And what it gets is, it gets the last value and complete. So technically, you can use this as a way to store like the last value, right? You could subscribe to this and you will always get the last value for completion. It's like, it's a tiny data store if you so want, this async subject. I hope this illustrates the fact. Same thing for error. Let's go and do the error case to see mostly what happens with the guy that joins afterwards. See here again, this guy is already done. We press error, it gets the error message. Here it says observer 1 gets error message. Now, after this is done, as I said, once I error, I cannot emit more values. It's done. This remote control said error. Error means no more values. Now the second guy is coming and subscribes to it, and see, we also get the error because we are now in an error state in this async subject. This is done. This is in an error state. We get the error, so we can even hold onto the error. Good. That was async subject. Behavior subject, one of my favorites. Behavior subject is what I call the stateful subject because you can use it to essentially hold data for you. What it does is you can give it a default value. So it has state right from the beginning. You can initialize this thing to default value. So once someone subscribes, if there was no emit yet, if I didn't press any buttons on my remote control yet, you will get the default value right away. The moment you subscribe, you get the default value. If I pressed my buttons a couple times, I will get, once I subscribe, I will immediately get the last emitted value. So let's assume, or we will just look at it. Oh yeah, and afterwards, it will just emit regularly. So I press my buttons, it will just next whatever is there. New subscriber, I have not pressed the button yet, we get the default value. I press buttons, subscriber comes, it gets the last button I pressed, right? Let's look at this. I have illustrated this in this demo here. So mpxt as note, thank you, 07. There we go. So again, what happens? Here we have our behavior subject. I give it this initial value. Here, first observer registers, it will get the initial value because no value has been emitted yet. So I press my value 1 button. So now I emit this. So observer 1 will get this value. Let's, you know what? Let's run it. So we can just do the parallel thing and don't go through it twice, right? So here, initialized, first observer immediately gets the initial value. I press value 1 button and we see observer 1 immediately gets this once I press the button. Now there's observer 2. As it is how behavior subjects work, observer 2 will get the last emitted value. So essentially the current state of our behavior subject, the current value of it, and the last value it emitted was value 1. So it will immediately get value 1. Now I press on my remote control, press value 2, and we see observer 1 and observer 2 will get value 2, right? Because it's listening to our data update. So behavior subject's really great if you have a variable that you want to watch. You want to have, it is a state, it is stateful. I can actually access this synchronously. If I go source $value, right? There is the way to access this synchronously. So if you have a subject where you have a variable that you want to observe, like the user, the current user, right? The current user is a state. In the beginning, it's undefined. Once the user registers with your system, you have a user. The user changes, you want to notify your system that the user has changed. I should not shake my screen that much, my desk. So this is really good for, essentially, I call it the stateful subject because I had a state and you can watch this state update. And then again, the last guy joins after the party and he gets nothing. Why? The thing is completed already. It doesn't get the latest value or anything because there's nothing. The thing is completed. This is how behavior subject works. Again, for completion, we do the same thing with error. There we go. Here, everyone gets the error message. So the late to the party guy gets either the error or the complete. The other guys just work as intended. Perfect. That was the behavior subject. Really useful. I use it a lot. Replay subject, also interesting. What a replay subject does is it emits the last n values. So it has like this kind of buffer, or yeah, let's call it buffer if you so like, maybe. So you can tell it how big this buffer is, and it will remember the last n values, n is the size of your buffer, it will remember them for you. And once someone subscribes, it will replay them for you. That's why it's called a replay subject. Let's go to replay subject. We create replay subject with a buffer size of 2. So what I do is then next I press value 1, value 2 on my remote control. So my buffer is full with values 1, values 2. First observer enters the game. Let's start this thing. It's example number 8. There we go. So here we go. I press value 1, value 2, first observer enters the game. It immediately gets these 2 values despite joining after the fact. Immediately gets these 2 values. Then I press 3 and 4. Because we are connected, we get value 3 and 4. Now, the state of my replay subject, it holds value 3 and 4 because these are the last 2 values. Now the next guy joins the party and it gets the current state replayed to it. So as you can see, once number 2 connects, it also gets values 3 and 4. I press my button for 5. Then both of them, because they're still connected, get value 5. Now the replay subject is holding value 4 and value 5, the last 2 values. So what happens after I complete? Well, we get the complete message. And now the question is, what happens to someone joining late? Well, the person joining late gets, as is said, once you subscribe, you immediately get replayed the events that are in your buffer. So you get event 4 and 5 and complete because we are completed already. So even if I subscribe after this thing is completed, we get this state. So now let's look at the error message. What's happening if we have an erroneous thing? We still get on subscription, we get the values in the buffer and we get the error state. Perfect. Those are the 4 subjects you can play with. Good. Now, as I said, a really big part in operators are a really big part in Rxjs are operators. As I said, my time is limited, right? We are already at it for quite some time. So operators, I can just show you a thing, namely how to read these marble diagrams and what are marble diagrams. But if you are interested in learning more about operators, which I can really recommend because there is no black magic behind it. It's really good once you understand what's actually happening and try to tease it before. You will see that at a later date. But what I want to show you here is, if you're confused about what an operator does, there is a site called Rxmarbles, which will help you figure out what an operator does. So I want to teach you quickly, very briefly, how to read these things. As I said, an operator, technically, it replaces your observable with a modified 1. Every time you have this pipe with these operators in it, each one of them is an observable and it will replace the one it subscribes to. So you're just subscribing to the one up in the chain. Let's look at this picture. What this picture does is we have observables up here. They are these lines, and these dots, the colored dots, are emissions on that observable in time. So this is just a timeline. This thing, this whatever, dash line, whatever, indicates when an observable completes. So this is the completion event. So we have 2 observables. This one is emitting 20, 40, 60, 80, 100. This one is emitting 1 and 1 at this point in time. So if we use the merge operator, it gets these 2 observables as an input, and the result will be a single observable that will emit the values at that point in time. So 20, 40, 60, here's the 1 of the second one, 1, 80, 100, 1. So if you go to rxmarbles.com, let's see, I should have a browser here somewhere. You can actually pick one of the operators and get a feeling for how they operate. And I showed you in the beginning, there was Concat, right? I wonder if we can find Concat here. There's Concat. So as I said in the beginning, what Concat does is it concatenates 2 observables, or not 2, like as many observables as you like, once they are complete. So what you can see here, we have a first observable up here. It emits the values 1, 1, 1 in these distances. What's cool about this, I can move this around when the emission happens. Then what you see is once the first observable completes, it subscribes to the second observable, which emits values 2 and 2 in this distance, as you can see here. So if I move this completion of the first one thus the subscription to the second one will begin, right? If I move these two apart, you will see that they move apart here. If I delay the execution of the first one, I can move this around. So if I move the complete back, you can see this is what Concat does. If it errors here, this thing will error. So this is to help you to get like the most common operators and look at them and get a feel for how they work. If they like, it's to help you decide. Actually, it's to help you understand what an operator does in a kind of interactive way. This is what I want to show you here. This is what I wanted to explain how to read these, because we do not, unfortunately, don't have much more time to talk about of operators, because there's more things we need to talk about, namely unsubscribing in completion. A lot of times you see, especially when working with Angular, there is the question, do I need to always unsubscribe? And I try to help you answering this question. This is what we try to do here. We try to answer questions, namely, do we always need to unsubscribe? Let's quickly talk about again what unsubscribing does. Good. So unsubscribing means I want to cancel or disconnect from our source. So what happens when unsubscribing? As you remember, in our observable, there is this cleanup function, which is called when we unsubscribe. So, but unsubscribing is the action of the observer telling the observable, I'm done. Deregister me, do not notify me anymore. This is what unsubscribing is. As I told you, the source essentially has a list of all of the observers, so it knows where to call the next function. And then one of them will tell you, oh, I'm not interested anymore, so you can throw it out of the list and not notify it anymore. This is what unsubscribing is. So the good thing about unsubscribing, an observer can perform cleanup logic. I've showed you that. So if in the case of HTTP requests, or unsetting timers, right, in the case of our timer example, once our observer unsubscribes, we can clean the timer, or we should clean the timer. Same goes for closing WebSocket connections, database connections, HTTP requests can be canceled. All of this is how powerful this whole unsubscribing notification thing is. Promise cannot do that, right? So it will also stop the subscription from executing because you're not listening to updates anymore, right? If you are like in a component or something, you're like, oh, there's the source and I subscribe to it. And then there is a logic that's run once there is a value coming. Once you unsubscribe, obviously, this logic is not executed anymore. If you do not unsubscribe, this logic will execute when there's more data coming. So how is this a problem? And I try to illustrate that. I hope I get it to run with the profiler of Chrome to show you what the implications of this are. Because your subscription technically could potentially be a closure, right? You're binding potential values or objects in that closure. And if you do not unsubscribe, it can never be cleaned because your source, your observable, still has a reference to your observer, and your observer still has a reference to the object. If you do not unsubscribe, it will be held there indefinitely. It cannot be garbage collected. This will cause memory leaks. So that's why unsubscribing is important. Next, there is ways to unsubscribe apart from calling the unsubscribe method. Actually, I've never shown you how to, I've shown you in the other examples, I'm calling the unsubscribe method, but you can call the unsubscribe method, or you can unsubscribe via operators that do that for you, right? Again, an operator is essentially also an observable that subscribes to this observable. You subscribe to the operator. Once that thing kills, it can, well, the behavior is defined in the operator, but technically it can unsubscribe for you, thus completing you, thus your subscription will be unsubscribed, because remember, completion unsubscribes. Good, can do that via operators. Then again, when the subject completes, right, your hot observable completes, or any observable completes, observers will unsubscribe. This is all related to unsubscribing. We've seen all of that. Now let me show you the implications of not cleaning up your subscription. What I did here is, this looks bit complicated, but this is a very simple setup. I do have a service, a data service. This data service has a hot observable, a subject. And get data just gives me access to this subject, right? So I have a component which gets this service. It has a reference to the service. And once the component inits, it connects to the observable in that service. So we do the get data, we get the observable, we subscribe to it, we create a connection. So every time we get a value, we want to update our last value thing here, our last value variable. So every time data goes through, we update this value and we do the console log here. When the component is destroyed, we, as good citizens, we unsubscribe. So what do we do? This is the basic setup of my classes. So this is essentially what happens. We create the service, right? This is created once. Now what I do is I create 10,000 components. I create a component, I call the init method, I call the destroy method. I do this 10,000 times. As you can see, this C is never held outside of this loop. So that means I create them, I do the init, destroy, and then it can be garbage collected, right? So it is out of memory. Perfect. So then I will just, after doing this, I will just log this out for me. And then after a timeout of 30 seconds, I will call the next method on this data source, right? So I create all of these components. They are all initialized. They're all destroyed. They're all freed from memory, potentially. After 30 seconds of this happens, I will send a value through the data stream. Then I do waiting 20 more seconds before I kill the program. So we have time to react to this, right? So after 30 seconds, sending value. So first 10,000 components, init, destroy. Then after 30 seconds, send the value through the data stream. Then 20 more seconds, kill the program, you're done. Let's run this. So let's first open my profiler here, perfect. Now let's run this and pm run leak. Compile, let's run. Good, it created 10,000 components. We can now inspect and use the profiler, the memory profiler, and we can get a memory footprint. We see we are now using about 3 megabytes. And you can see if we look here for component, there are no component classes anymore. Why? There's no reference outside of this loop that holds this component. So as I said, they can be garbage collected, right? Good, now 30 seconds should slowly pass. There we go, they passed. And now we can do another memory footprint because as you can see, the value here after 30 seconds, we emit a value, we can see nothing happened. Nothing happened here. We can look at the second snapshot. We can look at component, still no components, perfect. We can do a comparison with the one before. There's a lot of stuff that we are not interested in, but there's no components here, right? Good, this is what I want to show. Now let's assume we would not call this destroy method up here. Or we would not do the unsubscription here. Doesn't matter where I do it, but let's assume I would not run this destroy method, which does not run the unsubscription. Good. What happens is, so I want to show you, let's compile, let's run this. Again, we are creating 10,000, we do the init, we do not do the destroy. So let's get a memory footprint. Ah, damn it. I need to reconnect this thing. Now let's get the memory footprint. We can see we are at 8 megabytes. Why? There are 10,000 components. Why are there 10,000 components? There is no reference. Nothing is holding this component here. Why are they still there? Well, they're still there because we are not unsubscribing, right? And this is what we call memory leak. See, despite these components not being there anymore, not being held, you can see 10,000 times after I emit this value that this subscription logic is still run. And this is what's happening here. In this subscribe, I give this observer object to my source, to my observable, in this case, this subject, and register with it. Thus, I'm binding this component variable to this subscription. Because I still have the reference in this subscription here, I cannot garbage collect the components. Oh, damn it. Maybe let's see if this still works. Yeah, damn it. It was a bit too late because this program is already killed. But I think you get the idea, right? There were still 10,000 components running, and they're not cleaned up. They're cleaned up once the program is done. I think I illustrated that. So now what I want to show you, what happens, and here's the question, for example, do I need to unsubscribe from HTTP GET? Technically, you do not. If I just do this, once I subscribe to this data source, it will immediately emit 1. Let's again do the unsubscription. Here, it doesn't even matter if we do the unsubscription, because this thing will complete after 1 value. This thing will complete after 1 value. So what we see is, we wait for this. This time, let's not miss it. Whoops. Yeah, of course, because it's an observable, I need to, it's not a subject anymore. I cannot next it. It doesn't matter. Here we go. There we go. We see setting value happens 10,000 times immediately. So let's go for inspect. Let's go for the memory profiler. Let's see. And we see we are cleaned up. Why are we cleaned up? Well, simple. We didn't call destroy. We didn't unsubscribe here. But because this thing completed, we unsubscribe. Because we unsubscribe, this object is thrown out of the list of observables that this thing holds. Thus, there's no reference holding this component anymore. It can be garbage collected. Same thing happens if you were to do like the behavior in a subject pattern where this is a subject. I should have, yeah. Go for subject, right? Same thing happens if I were to complete the subject after emitting 1 value. So let's kill this. Again, here we are not unsubscribing like this. We run the leak. Let's prepare to not miss it. There we go. We inspect. Thing is running. We get a memory footprint. We get 8 megabytes, right? Because there's 10,000 components. Let's this time not miss it. So let's wait for this thing to run, to emit the value once. Should happen soon. Maybe I should make, well, less than 30 seconds and I will miss it. So recreate the components. We're waiting here. It emitted the value. Let's go for another snapshot. We still see components. We completed. Let's give me this. Come on. There we go. Was a bit too early. See, done. After this done, waiting for 20 more seconds, this is where we have the snapshot. And now we can see, if you compare this with the one before with snapshot 2, and we look for component, we see 10,000 components have been freed, right? So if you look here, summary 3, no component, summary 2, component, 10,000. See? Now, I hope this illustrated a bit how all of this plays together in terms of memory leaks, because the question was, do we always have to unsubscribe? This question is technically hard to answer. You don't always have to unsubscribe. Well, not directly, because you need to know what you're doing. This is just a library you're using. You need to define the behavior that you want. So always unsubscribing is the, how to say, rule of thumb, right? If you always unsubscribe, memory leaks cannot happen, right? The question is, do you always have to unsubscribe? Technically, no, if you know what you're doing. So when you're getting started with Rxjs and Angular development, always unsubscribe. Why? Even from the HTTP client. Because imagine you're on a component, an HTTP request starts, you navigate away from the component. Then the HTTP request returns and your subscription is still there and will be executed on a view that is potentially not there. Now the question is, do you want this to happen? Do you want the subscription, the next function, to still be called when the component is not visible anymore? Depends. Imagine you want to log it down that the thing returns. Even if the component is not visible anymore, you want to log it. For example, this HTTP request is only a for example, for data collection purposes, someone opened this view, right? If you would unsubscribe when navigating away, this HTTP request will be cancelled. Your backend will never know someone was there. But in case you do not unsubscribe, even if you go away from the component, this thing will be called, your backend will know someone was there. So it's essentially up to you whether you want to unsubscribe or not. But rule of thumb is always unsubscribe, no memory leaks. But what you should rather do once you get more familiar with Rxjs, unsubscribe cleverly. You need to know how your data flows. You need to know when your hot observable is emitting data, when you want to complete it, when not. You need to decide. You need to be able to reason about what's happening in your application. And once you reach this level, it will become second nature. You can tell, oh, there's this operator, so I know this completes, thus this is executing this way, perfect, right? So because you can unsubscribe with operators, for example, with take until, take three, first, last, right? With all of these things, they unsubscribe. Well, last doesn't unsubscribe for you technically because it only happens when it completes anyway, but there are operators that do unsubscription for you. Or in Angular, once you bind to the async pipe will unsubscribe for you once the view is destroyed, right? There are several ways to do this whole unsubscription business. So you do not always have to unsubscribe explicitly. You just need to know how your program is working, right? Good. There was a lot of stuff. So what I want to show you is some resources that you can use to help yourself. The biggest one is learn Rxjs Io. What happens here is, I use this a lot if I want to talk about, because there is like a ton of operators, right? These are all the operators there are. It's like hundreds. Sometimes I need to look up an operator and see if there's an operator that does what I need, right? Here is essentially the page you can go for, right? For example, start with, right? Start with, if you put it in a pipe, if someone subscribes, it will start with this value. Like on subscription, it will immediately emit this before it emits the other stuff, right? You can look all of this up before you look into the source code, because sometimes the source code of Rxjs could be hard to read. So my recommendation, learn Rxjs, is really helpful with looking up operators and getting an explanation and example code with it. Rx marbles, I've shown you already. You can look at it to get a feel. Like after you found your operator, you can play with it and see if it does what it does. Then the next step would be going to StackBlitz. If you go to StackBlitz, you can create a sandbox, a playground, just like I did on my local machine. You can do that here. And then you can play with it, put your operators, put your architecture in an isolated space right here and see if the things behave the way you want. For example, if you want to go start with, we just go start with and say whatever, emit a value instead of the first value that this thing emits is word. So let's just go with viewers. Let's import this here, start with. So what happens is before word is emitted, viewers will be emitted on this stream and will be mapped to this string. So it will say hello viewers, hello world, right? You can play with this on StackBlitz. Really good, really good. I do this a lot if I have like a more complex architecture. For example, there was a problem with scrolling, which I will introduce in like potential third part of this webinar series, right? Last thing is the operator decision tree. Is really good too. I will have to pull this from a different screen because I'm not gonna type this URL. Let's take you here. There we go. If you, come on, go here. Perfect. If you're on the lookout for an observable, this operator decision this operator decision tree will help you find it, right? So for example, I have a couple of observables, right? Let's assume I have 3 observables. And what I want is, I have 3 observables that do HTTP requests, and I only want the value of the first one that emits and disregard the others. There's an operator for that. right? For example, this one, I want to receive values only from the observable that emits a value first, right? Or I want to be notified when all of them have completed. Let's go with this. So there is fork join. If you look at fork join, you can join these operators, these observables together, and it will only, it's similar to join in other thingies, in I think promises, or is it called promise.all, I think is what's called. Fork join does that. You have 3 observables, you only want your subscription to run once all 3 of them are completed. Fork join does that. Or the example I had before, race, right? Race is, I have 3 observables, I only care about the one that emits first, the other one can be canceled, and here we go. Race is for that. Operator decision tree can help you find your operators. Good. That is that for a very quick kind of rundown on all the bits and pieces that are running in, or all the moving parts of Rxjs. I hope this rather brief introduction helped you maybe pick up something you didn't know, maybe help you answer questions. For example, the one from Christian Fahl, which should be answered now. We can now use this time to answer more questions. If you have questions or feedback to me, you can do it right here, or please remember, in case you're done and have no questions when you exit the webinar, I would mean a lot to us if you give us some feedback. And without being too much of a shill, there's one more thing. If you're working with Angular, if you go to thinktecture.com, my name, I have lots of resources, blog posts there's essentially 3 blog posts, I think, about Rxjs that talk about some Angular patterns and anti-patterns, but for example, subscriptions and illustrate why that is potentially a bad idea. Go to the website, you can find it there. Subscribe to our Twitter or whatever you do with Twitter. Follow us on Twitter so you can see if there is when the next part of this will go live. So far, thank you for everyone who's been watching. I hope you got something out of it, and I hand it back to Göran.
Yeah, thank you, Yannick. That was a lot of stuff and topics, and thank you for your explanations. Really great. And well, from my side, I have a question, but this one is not for you, it's for our audience. And we wanted to know from you if you've got already experiences with Rxjs, and at that point I will start a poll and would like to ask you to give us some feedback. Well, Yannick, as I said, that was a lot of topics, and I really liked your explanations and the passion showing by this topic.
Well, I get emotionally involved in this, so
yeah,
I guess you could tell, yeah.
Yeah, sure. And so I think that's the majority of the topics are really clear after this talk. And so I think that's why we don't have so much questions. And well, so for everybody, if you run into any questions afterwards, please reach out to Yannick or to me. You can just email, Twitter, whatever you like, and yeah, come over with some questions or ideas. Let's get in touch. Let's talk. And I think before saying goodbye for today, I think we should take a look at the poll. Yannick?
Yeah, let's take a look at this. That's interesting. So there are a lot of Rxjs users, which I've pretty much expected. And one of them, the last question was like, we have deeper questions. There's one thing, as Göran already mentioned before, are the links. Actually, you will get access to the slide deck, but I can paste the links there if you need them for quick access. I will do that for you. But once, I don't know exactly how it works, but technically after this is done, it will be uploaded to our website as well. And then you can get access to the slides, to a recording of this, and then you have it. Let's see if this works. Yeah, I think the operator decision tree didn't fit in there anymore. Let's go with this. There you go. And again, as Göran said, you can connect with us. You can send us an email if there's one more question. I'd love to take my time to reply if I can answer your question. And yeah, thank you very much again.
Yeah. As mentioned at the beginning of the webinar, you will find these links in the slide deck we will send you by email, and so you will have it.
You will also get the source code, right, of my
Yeah.
examples. It is also already up there on. You will get all the links. You will get everything there is in the post-processing of this webinar. So don't worry, you will have access to everything I did here and can play around with it yourself.
Yep, exactly. Yeah, this would be all for today. Yeah, please feel free to leave us a feedback after leaving the webinar, and have a great time. Stay safe, and see you at our next webinar. Bye-bye.